I will go ahead and introduce myself. I'm Nick Thompson of the Oak Ridge Computer Graphics Department, and I'm pleased to introduce today's speaker, Dave Pugmire, who will be teaching us how to use VisIt. And I am very excited to learn to use VisIt because I crash ParaView all the time. And every time I crash ParaView, I think, I need to learn VisIt, and I never do. And so today, I finally got an excuse to put some mental effort into learning how to use VisIt. So without further ado, let's give it up for Dave Pugmire, an OG of VisIt, and also my boss.
Let's see. All right, hello everybody. I appreciate the invitation to talk a little bit about VisIt. Can everybody, is my screen being shared okay by everybody? Everybody see it okay?
Looks good to me, Dave.
Okay, great. So I'm gonna go through just a few slides to sort of provide an introduction and grounding of what VisIt's all about. You know, the link for downloading VisIt was in the email, and you can download that and play around with it. You know, you can either kind of try to follow along with what I'm doing, or it's also useful just to watch what I'm doing and just sort of get an idea of what's possible. There in the future, the near future, I hope we're going to be doing an all day long VisIt tutorial where it'll be more hands-on, and we'll get into the details. So. Anyway, here's a link. Here's where all the stuff's available, where you can download it. There's a ton of tutorials, and you know, here's the GitHub, the mailing list, et cetera, et cetera. So, first of all, yes, we all admit VisIt has a horrible name, because anytime you Google for VisIt, you're probably not getting the VisIt we're going to be talking about. But you know, it is what it is. It's stuck, and so here we go. So what is VisIt? So it's an open source production quality tool for doing analysis and visualization on very large data. It runs on laptops, it runs on workstations, it runs on supercomputers, it runs across the whole gamut of things. And it also supports a very wide set of use cases. It has tools for playing around with data and exploring it. It has quantitative analysis. One of the dirty little secrets of visualization is it's a great tool to use to try to debug your code. You do things like comparative analysis, and then also making high quality presentations to go in, or graphics to go in presentations or papers, etc. And so VisIt has a whole host of different capabilities in it, and here's just a what is there, 6 there? So just a brief viewing of 6 of the capabilities in there. There's a very active community and large community that's involved with VisIt. It started way back in 2000 in the Ask program. It's hosted at Livermore, but there's people who are working on it at a number of different laboratories and universities, and so you can sort of see some of the highlights in VisIt's evolution. So what VisIt is it's a way, if you can put your data on a mesh, or maybe your data is already in a mesh, then you can load it into VisIt and look at it. And so there's a lot of different meshes, point meshes, curvilinear, rectilinear, structured, unstructured, time varying, et cetera, et cetera. And on that mesh, there's a number of different fields. There's scalars, vector tensors, material volumes, fractions, and species, et cetera. So there's a lot of different data that can live on the. See, I'm going to skip over that one. That can live on the mesh. Now, one of the most common questions we get is, okay, VisIt's awesome or ParaView's awesome. Now, how do I get my data into it? And so there's a whole tutorial that describes. There's a number of resources that describes how you can get it in there if VisIt doesn't support your particular file format. This is old. It's way more than 110 now. But yeah, there's a bunch that support it. It also has a flexible platform to do a lot of other interesting custom work. So it's got a C++ plugin architecture. One of the most powerful things that we don't have time to get to today is the Python interface. So anything that I do in the GUI, you can do in Python, and you can automate it. It also does in situ coupling as well. Let's see. So I'm going to skip over these. So VisIt runs in parallel. Distributed memory parallelism, and the idea is, so if this is what your data set looks like, typically as the simulation writes the data out to disk, each rank, for instance, will write a little subgrid of this larger grid, and so VisIt will parallelize on this spatial decomposition of the data. So one rank in VisIt could be defined to each, could be assigned to one of these little blocks in the larger data set. And so here's sort of the core concepts, which we'll go over when I start to do a demonstration. There's the concept of a database, which is how data are read from a file or from in situ. There's plots, which render the data. And then operators perform manipulations, transformations, different operations to the data. Expressions are a way to generate derived quantities that aren't, that don't exist in your file. And then it has a query capability so that you can ask questions about the data and get summary statistics, et cetera. So typically what you do is you'll open up a database, and then you'll plot it, or you could also stick an operator in there to change the data before it's plotted. And you can stagger these together. You can do a bunch of operators. So for instance, you could slice it, and then you could elevate it, and then you could render the density variable, for example. The other thing that you can do is from the data that you read in, you create some expressions, which effectively creates new variables that then you can use in your analysis and visualization. Let's see. So yeah, so this can get, these can get quite complicated. You can mix and match all these things and even throw a query in at the end. So anyway, so I'm gonna drop out of that and go to a demo. So while we're switching over, any high-level questions about what I just talked about? We all good? Okay. If there's something that looks funky, or you want to see how to try to do something else, just holler, and I'll show you how to do it. So, okay, so this is, hopefully you can sort of see my screen. So when VisIt fires up, there's two windows. This window right here is called the viewer window, and that's where everything's going to be drawn. And then this is called the GUI. Now, the GUI is optional. The GUI is just a way, it is sort of a graphical interface for interacting with VisIt. But as I mentioned, VisIt can also be controlled with Python. And so when you fire it up, when you run it with Python, of course, the GUI doesn't show up. You can pop up the GUI in Python and actually can control it through the GUI or through Python. So there's a lot of flexibilities in how it's controlled. Okay. And so the first thing that I'm going to do is I'm going to open a file. So you go over here to this open icon, and this little prompt comes up, and there are some test files. If you go let's see, if you go to the installation, let me see, let me go down to VisIt. There's VisIt, contents, resources, data. Okay, so here's a bunch of test data that comes with the installation. So I'm just going to open up this file called noise.silo, which is just a thin-setted data set. Now you notice when I opened it up, it doesn't do anything, and that's because if I'm firing this up on a supercomputer and reading 20 petabytes of data, I don't want it to do anything because it might take a while. And so it shows me my active source is this noise.silo file, so I've got it opened. And so let's take a look at what's inside of here. So if I go down here to this, add a plot, I hit the add button, and now it shows me all the different types of plots that I can create. And so a very common one is the pseudocolor plot, and I'm just going to pick this variable called Hardy Global, and I'll click that. And now you'll notice here in this window right here, it's shown me that I've, the variable, this is the variable and this is the type of plot. And again, it hasn't done anything because I might not be done. I want to make some changes to it, but it also, might be 10 petabytes of data. And so, you only want to do it when you're ready to draw. So, okay, so I hit the draw button and there we go. So, I've got a square mesh and, it's applied a color map to it. And sort of to see what the data is. Yeah.
Quick question. Could you show me where you found that example data one more time?
Okay, yeah, sure. So at least on a Mac, so if you go to if you go to the VisIt directory and it's in contents, resources, data. Yes, actually right there. I'll put that path in the.
Okay.
Yeah, for Windows or Linux, it's going to be someplace else, but it's basically going to be, it's not going to have contents resources, but in the installation directory, the data will be there. Okay. All right. Okay. So let's we can add multiple plots at the same time. So let's say we're interested in seeing what the mesh looks like. So we'll do a mesh plot, and again, when I hit draw, then it's going to draw my mesh on top of my other plot. Okay, so this looks like a nice structured data set, uniform or rectilinear. And then I've got these buttons up here where I can, I can hide or show different, different things, each of the plots independently. Okay, and so let's delete the mesh plot. We're done looking at that. So delete it and it goes away. Okay, so how do we want to? Okay, so let's try to make this a little bit better. So if you double click, if you double click on the plot, then the plot attributes will come up. This plot attributes window, and you can here you can make a lot of different changes. So it's the scale is linear. I could change it to log, and then when I hit the apply button, my plot will update. So you can see what that looks like. So let's change it back to linear. Let's set the min and the max to. Now, if you'll notice right here, the color bar shows you the min and max of the data. So let's just set that to 2 and 4, for example, and hit apply. And there you see our color bar is updated, and of course our plot's changed. The other thing that we can do is we can use a better color map because the rainbow color map is not the greatest. So there's this hot desaturated, which is kind of a nice one. So if we color it that way, then we can see it's not just sort of a green mess for all those internal values. So we can see some of the structure there, and there's a whole bunch of different. There's all kinds of different color maps in here. That's a horrible one. And there's also, I won't go over this now, but there are ways to create your own custom color maps, which are pretty easy to make. Okay, so there we go. Okay, so this is called a pseudocolor plot, and it's essentially taking the data, the external, the mesh, and just applying, and coloring that mesh by whatever variable you've selected. Okay, so let's do something more interesting and add an operator to this. So if I go click on my operators, I can see that I've got a number of operators here, and let's see. So there's a slicing one where well, let's just slice it. That's sort of the easiest thing. So now you'll notice in this window right here, I've got my variable, my pseudocolor plot, and now I've got a slice operator performed in there. So if I hit draw, now it sliced it and it gave me a 2D. Now I'm in a 2D window, and so I could check that. Okay, sorry, I'm going too fast. So if you come over here and double click, just like on the plot, on the operator, then you've got a number of different options for changing how this slice works. So, you know, it's set to y-axis. I can change that to the x-axis. And oh, and then I also uncheck the project to 2D. So now it's showing, you know, this slice through the data, but in its, you know, in its, it sort of retains the 3D setting of it. So there's the Z, and there's a number of different ways that you can change. You know, so this is a percentage along the Z-axis. You know, so you can move, you know, you can move that around, and you can also do like a point intercept where you have, you know, more control on how you set it. So anyway, so that's the slice operator applied to a plot. Now, to get rid of an operator, if you don't want it anymore, is you can just hit that X button, and then you hit draw, and then you've got your plot again. Okay. All right. So let's try something that's slightly more interesting. So we go back to slice, and now let's do an isosurface. Okay. So the same thing. And so if I hit draw, all these operators have default settings. And so if I just hit draw without changing anything, I just get whatever the defaults are set to. Okay. And so if I double click on that, then I can see what are the different options that I have. And so the default is and so it just takes, you know, it takes the min and the max of the data, and it takes 10 uniform samples, and that's what the ISO values are. So I can also set it by values or percentage or percent. So if I know that I'm interested that you know, my Nobel Prize is waiting where this variable is that, then it will show me, you know, just a single surface. I can add in multiple values. Let's see, just like that in a list, and now you've seen I can see those other surfaces in there as well. Now these, you know, so there's two surfaces right here, and they're both red, and the reason that they're both red is because, see, one has an ISO value of 4 and the other has an ISO value of 5, but my color map only goes up to 4. Okay, and so they both get set that red color. So if we come back up here and uncheck min and max to say just use whatever the min and max of the data are, and then hit apply, it updates my color map, and then I can see, you know, features with those values. Okay, I can also do percentage, and this is just a percentage between the min and the max. So you know, it's actually in decimal. So 15.5 point, you know, like that, and that will give me oh, maybe it is. I haven't done this in a while. Maybe it is. Maybe it is. Yeah, maybe it is. Yeah, it is. I'm sorry. It is percentages, not fractions. Okay, so there you go. So a lot of different ways to make ISO contours. Okay. Any questions there with what we've seen so far?
Can you slice the ISO contours?
Yes, you can. Yeah. So you know, you can chain these together any way you want to. And so let's see. Let me make the ISO surface a little bit more interesting so that we can get a. Well, let me just set it to n levels, because that will for sure do it. Okay. And then if I just go here and I say slice, do a slice, then it gives me, you know, a slice of my 3D contours, which, you know, just gives me 2D, right? And you know, I could chain these things all together too. So for instance, I could go to transforms and make it and create a transform operator. And then I double click there and I specify, well, let's say, let's scale this in a non-uniform way so it's obvious what happens. So I'm going to scale X by 1 and I'm going to scale Y by 5. Okay, so it'll stretch it in the Y direction. Okay, hit apply, dismiss, draw. Okay, so now you can see that it's stretched in the Y direction. Okay, yeah, so yeah, great question. So you can chain these together in a lot of different ways. Now, you can't chain them in arbitrary ways because it could be that, you know, the input that an operator expects is not, it doesn't match with the data that you're giving it. So for instance, like if you added a streamline operator and you don't have a vector field, then that's not going to work, right? It'll complain and say, you're not feeding me the right data. So, okay, so let's go back here. We've got our ISO surface here. Another important operator is the ISO volume, which that's in the selection. Okay, so I'll add an ISO volume, and here it's an ISO contour on a min, an ISO contour on a max, and then it fills in everything between. So let's make an ISO volume between 3 and 4, and then hit draw. Okay, so now see I don't have surfaces, I've got a volume where everything in that volume is between 3 and 4. Okay.
Hey Dave?
Yeah.
Is this doing a volume render on the fly?
No, this is just a surface rendering.
Oh, it's surface render. It could be volume rendered though, with the
right.
ISO volume.
Yeah, and I'm going to show you volume rendering in just a second. Yeah.
Okay.
Yeah. Good question. Now the other thing that we could do, you'll notice that, you know, my ISO volume is being done on the same variable that I'm coloring by. Well, it doesn't have to be. I could change that. So you'll notice in my operator attributes, it says variable, and it's right now it's set to default, which that just means whatever's coming down the pipeline, I'll take that. Okay, and so since our primary variable is Hardy Global, that's the one that we'll use. But it doesn't have to be. I can change it. So if I click here, and I can see, here are all my other variables. So let's set that. Let's set this one to just this other one called Shepherd Global. And now when I hit apply, the colors will stay the same because I'm still coloring by Hardy Global, but the shape is going to change because now I'm ISO voluming on another variable. And so you see this one looks very, very different because, so we're slicing it on one variable, coloring it by another. Okay.
Is it possible to make derived data by adding 2 different fields together or something?
It is, yeah, and that's and I'm going to show you how to do that in just a second. Yeah, you absolutely can do that. It's called the expression editor. Okay. All right, so let me show you a couple of other plots to give you sort of we'll delete this one. We're done with this. So there's also a contour plot, which does kind of this. It's essentially it's a pseudo-color plot and the operator all put into one. But contouring is such a common thing that people do. We've squished it all together into one thing. And it has different ways of specifying the ISO values, and it has some tools down in here for manually setting what you want the colors to be, so you can change it up, change it up. And also, all the plots have this legend button, so if you hit that, then the legend will go away if you don't want to see that. Okay. All right. So that is the that's the contour plot. Another one that someone mentioned before was the volume plot, and so let's just go back to that same variable and do a volume plot of this, and so. Now this is the same data, but it looks quite different. It's kind of ghosty. Now volume rendering is a very powerful technique, and it generally makes the most stunning images. So if you've ever seen some just really, really nice visualization, chances are that it was done with volume rendering. Okay. All right. So let's talk about volume rendering. So if I double click here. Let me move this over so that we can see both at the same time. What volume rendering does, and I'll go over here to the transfer function tab to sort of give you a better idea of what's going on. So VisIt shows you, this is a histogram of all the values in that data set. Okay, and what volume rendering does is for each value it assigns a color based on, you know, this color map right here, and this white thing right here that's a triangle, that defines the it defines the opacity of that particular value. Okay, and so this is just a ramp function. I think it'll be more clarified. So let's just plop a little Gaussian right there. Well, let me make it a little bit bigger so it's easy to see. So now what I'm saying is that I only want to see, you know, values between this point and that point. And in the middle, where this Gaussian is the highest, that's going to be the most opaque. That's what I'm going to see. And then it's going to, you know, as I go away from that value, it's going to become more transparent so that I can sort of see through it. So if I hit apply, now you can see it's made, you know, a lot of the data go away, and it's only showing me, you know, the darkest ones are sort of these things that peak at, you know, wherever the peak of this is here in the color map. It's, you know, 2.5 or something. Okay, and so if I change the shape of this Gaussian and make it really narrow, then it's going to become much sharper. Okay, and so, you know, in the limit, this becomes an isocontour, because if you make that, you know, infinitely small, it just gives you just one single value. Okay. Does that make sense? Volume rendering can be a little confusing, and if you haven't played with it. Any questions about volume rendering? Sort of, at least the theory behind it.
So that technique that you just showed would be great for a Fermi surface where you have like a little bit of dispersion off the actual curve. I've never seen anybody actually do that before.
Yeah,
but I think it would be really cool.
Yeah, and volume rendering is a great way. It sort of shines when you've got volumetric data and you want to be able to see into the data, and also be able to make things, you know, transparent so that you can see. So, you know, a lot of X-rays will do it. You know, it will show you the bone. So essentially, you know, you put the transfer function where the bone density value is and make everything else go away, and then all you'll see is bone. But if you wanted to see a little bit of soft tissue, you know, so I can add additional Gaussians in here to see, you know, values at different places. Okay, and so, you know, if there's a set of features in your data that you'd like to pull out, this is the way that you do it. And it has some controls on here, so you can control the shape of the Gaussian. So, you know, you can turn them into box functions, you know, if you want. You can also just go right back here to the freeform. Now, when I go back to freeform, it shows me, you know, essentially what my Gaussians have done. So but I can also just sort of freeform it. So if I hit this button, which means just throw everything away, then I click and drag and I can make whatever shape I want, right? And so when I hit apply, I mean, you know, this is horrible. This is a really bad idea, but you know, you can do it. So you can do something like that. And it also has some presets, like you can do this sawtooth, which sometimes can be good. And so, you know, so that's what a sawtooth looks like. There's also this smooth button. So if you freeform something, and notice as I smooth this sawtooth they'll basically turn into a bunch of little Gaussians. And so the freeform is nice, you know, if you're sort of sketching something by hand and you want to smooth it out a little bit, this will sort of, you know, make it smoother, and then you can go ahead and look at what you want to look at. So yeah, volume rendering is a lot of fun. There's a lot of different knobs and controls for it, and you know, you can really make it. It's a really good way to explore your data and understand it. And just like the other one, I can also change the color map. So if I change it, let's see, I'll just change it to this hot and cold one. Now you'll notice that my color map here has changed, so that I get an idea of what's mapping onto what. Okay, and you can also set the min and the max, and the linear, the log. You know how, you know, setting the min and the max basically tells you, you know, what value starts here and what value ends here. So that gives you some options for, you know, narrowing in on the data that you want. And there's also attenuation, which just applies a kind of a transparency onto the result that you have. So, you know, I've dragged this down to 23%. Now I hit apply, that's going to become a lot more faint. Okay. And so that's another important knob for controlling. You know, basically, you know, helping you to see the things that you want to see, and hide the things that you're not interested in seeing. Okay. Okay. Any questions on volume rendering? Okay, in the interest of time, so yeah, so volume is a good one to look at. So someone mentioned expressions, and so excuse me. So I'm going to show you how to do expressions in the last few minutes. So I'm going to delete that, and then I'm going to close this. Well, I actually don't have to close that. I'm going to open up a different file, which is, let's see, noise. It's called noise 2D. It's just a 2D file. Where did it go? Oh, I guess it's not in here. Oh well, I'll just use the noise file. It doesn't matter. Okay. So I already had it open, so I didn't have to do that. Okay. So let's just put up our good friend the pseudocolor plot again of this data set, and then to make an expression, I go up here to the controls menu, and there is expressions right here. So I hit that, and then this expression editor pops up. Okay, and so again, you know what this does, it allows me to create derived quantities, you know, other things that I might be interested in looking at. So let's just create a new one. So I'll hit new. It gives me a new variable called unnamed. Let's just call this one ×2, and the type is going to be scalar. You know, depending on what kind of variable you're making, it can be vector, tensor, et cetera, whatever. This is just going to be a scalar one. And so now the definition you put down in here. And so now that there's these pull down menus down here to help you. And so if I say scalars, let's say, you know, we're going to use that same variable that we've been doing, and we're going to say ×2. Okay, so it's just that variable ×2. And then I hit apply. I'll just move this to the back. Now you'll notice. I failed to show you this this button right here. This is the variables, which will change whatever the selected plot is. It will change the variable it uses. So I can say, you know, so right now it's Hardy Global, but I could change it to Shepherd Global, and you'll see that the plot updated. Okay, if I change it back to Hardy Global, you know, it's a little bit different. Okay, now this new variable that we created in the expression editor is now there, ×2. It's now just like a normal variable, like it was written out into my file. Now, now this is not a very interesting variable because it just multiplies it by 2. But if you pay attention, you know, our min is 1 and our max is about 6. If we color it by ×2, that min and max is going to change, right? Now it's, you know, twice what it used to be. Okay, and so yeah, so that's my new variable. Now there's a whole bunch of other things that you can do that make it a lot more interesting. So we could do, let's create a new variable called coordinates, and that's going to be a vector. What I'm going to do is I want a vectored valued quantity that is just the XYZ positions of my mesh. Okay, so that will create that, and now let's make an X, which is going to be chords 0. Okay, and Y, which is going to be chords 1, and make a new Z, which is going to be chords 2. Okay, so now we've got X, Y, and Z. So I could color, you know, I could color it by X. I can color it by Y. Oops. Oh, did I spell that wrong? It's chords, not capital C. Sorry. Okay, so hit apply. Okay, draw. Okay, yeah, there we go. Okay, and now to do something a little bit more interesting, we could make a variable called distance, which is going to be the square root of everyone remember high school algebra plus y times y plus z times z point. Okay. Hit apply. And then now when I color it by distance, I'll get you know, the distance from the origin, which in this data set goes from 10 to minus 10, so you know 0 is right there in the middle. So it's coloring it by that. So okay. Yeah, you know, if you so we're sort of at the end of the time, and I wanted to have a little bit of time for some questions. But if you're interested in getting your hands dirty with this, you know, like I said, we're going to do a serious deep dive tutorial into this, and so you know, look for that when that's announced. So.